Okay, hello everyone. This is Sir Don, and we are on our very first remedial lesson, which is about sets. So this is our objective for today. The students are expected to describe well-defined sets and subsets.
Say set, this is a collection or group of well-defined and well-distinguished objects that follow a certain rule. So when we say a set, this is a group, a collection. It can be an object, a person, event, or anything that can be classified based on a certain rule. Some of the examples are, let's say we have a set of fruits, a set of vowels, a set of prime numbers. So these are actually descriptive words which describe the content or the elements or the objects that are present in the given set. So all these things, we call this one as a set or simply a group. So we have discussed about the set or simply a group. So if there's a group, there are members. We call these members as the element of a set. So this is a member of a set, and the symbol is like this one. This is read as element, which means belongs to, or is an element of, or is a member of. See, if you are part of the remedial class, that remedial class is a set and you is the element. You are one of the elements. Let's say for instance, we have example set X. We have the elements for set X which are A, E, I, O, U. So these items or these letters found inside these brackets, these are, braces, these are what we call the elements. So we can say A is an element of set X, U is an element of set X, I is an element of set X, and if a certain element is not part of the given set, we call that one as the not an element of a set, or in symbol, this is the symbol for not element of a set. So take note of that. All members of a group, those are what we call the elements. And if that member is not part of the group, we call that one as the not an element of a set. Things or writing the members of a group can be written in different methods. So we call that one as the representation of a set. The first way to present a set is what we call the description method. So from the word itself, description, this describes the elements enclosed in braces. Let's say for instance, we have set S. Set S, the description for that set S is a whole number less than 5. So this one is the description. The second one is what we call the roster method or tabular form. So we have here list of the elements of a set separated by commas. So in this way or method in representing a set, we are going to enumerate the members of the set or the elements of the set. Let's say for instance, we have S. The elements are 0, 1, 2, 3, 4 because these are actually a whole number less than 5. So pertaining to the first one, description method, if we're going to write the elements found in this set S, we have 0, 1, 2, 3, 4. This way of writing the set is what we call the roster method or the tabular form. And the last one is what we call the rule method or set builder notation. This one is one of the most common way or method in representing a set because this is always used in higher mathematics. So this specifies the property or the general rule. So if we have this description method which is set S is a whole number less than 5 and we have all the elements written in the roster method, if we're going to write this one using the rule method, we have set S wherein x such that x is a whole number less than 5. So x slash x, this is read as x such that x. Then going back with the description method, you're just going to copy the description of the given set. So for you to visualize what I'm talking about, well, let's have a 3-column here. 3 columns using the differentiation of the description method, the roster method or tabular form, as well as the rule method or the set builder notation. So let's say for instance we have set A. The description is a red fruit. To write this one using the roster method or tabular form, you are going to identify those fruits that are red. So, just write the elements. We have here apple, cherry, and then we have dragon fruit. Although there are also red fruits that are present, so you may write it here. So these are just limited. So you may write also additional red fruits here. Then to write this one using the rule method or set builder notation, you are going to write here x such that x and then just copy the description. Okay, another example we have set B is a prime number greater than 0 but less than 10. So here is the description of the given set. For you to write the roster method or the tabular form, you are going to identify those prime numbers greater than 0 but less than 10. Those numbers are 2, 3, 5, 7. And then going back with the definition of a prime number is a number wherein the factors are the given number and 1. So there are only 2 factors for that given number. The number itself and then 1. So what are those numbers which are greater than 0 but less than 10? Those are 2, 3, 5, and 7. Then the last method is the rule method or set builder notation. You're just going to copy again the description and then add x slash x, which is read as x such that x is a prime number greater than 0 but less than 10. Okay, our third example is that C or set C is a multiple of 3 less than 15. So when we say multiple, these are numbers which can be divided by 3. So we have here the roster method. So make sure that those numbers that can be divided by 3 are less than 15. So writing those elements, we have 3, we have 0, 3, 6, 9, and 12. Why is it 0 belongs to these elements? Because 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. Then 3 times 4 is 12. 3 times 5 is 15. Why 15 is not included? Because the description says it should be a multiple of 3 less than 10. Therefore, we say less than 15. When we say less than 15, 15 is not included. Because those numbers should be less than 15 and 15 itself is not part of the given elements. To write the rule method or the set builder notation, again, you're just going to copy the description and then add x such that x or x slash x. What we call subset. So when we say subset, this is a set which all elements are contained in another set. So when we say subset, if you have a certain set or certain group, there are subgroups that are present in that given group. Let's say, for instance, you have there all students taking remedial classes. If I say all males or all male students taking remedial classes, those male students are called subsets or subset of the given set. You are called the subgroup. Okay, let's say for instance we have an example here, set A from 0, 1, and 2. So 0, 1, and 2 here are called the elements of the given set. These are the members. So these are the members of the given set. Okay, so we can say now from that symbol that is subset, 0, 1, 2 is a subset of set A. Because this is actually a subgroup of A. Another one, 0 is a subset of A. Because 0 is a member and this one is considered as one group and this is subgroup of set A. 1 is a subset of A because again 1 is part of set A and this is subgroup of set A. Then 2 is a subset of A. 0, 1, this can be associated as separate group and this is a subset of A. 0, 2 is also a subset of A. Then 1, 2 is a subset of A. And also, a null set, or this one is what we call an empty set, is also a subset of A. So if you have here 3 elements, all in all you have here 8 subsets. We also have this what we call proper subset. So when we say proper subset, this is a set wherein, or this is a proper set if it is a subset of the given set and there exists at least one element in the set which is not present in the given set. So all this from here up to here, there are 1 or 2 elements that are not present in the given set. So these are what we call proper subset. This what we call equal sets and equivalent sets. So in mathematics, these two terms are actually equal, but if the topic is all about sets, these are entirely different. So take note, equal is not the same with equivalent if we are pertaining to sets. Because equal set, the symbol is this one, the equal sign that we use in an equation. These are two sets that contain exactly the same or identical elements. So again, the members of the group or the set here are exactly the same. They are identical. So which means that a member of one set is also a member of the other set. Or all members of the given set are also members of the other given set. Then we have also equivalent sets. In equivalent sets, we are just going to count the number of elements. If they have the same number of elements, regardless their description, they are called equivalent sets. Let's say for instance, we have here equal sets. Set A, we have A, B, C, D, E. So take note that we have here letters A, B, C, D, E. Looking at set B, we have also elements B, C, E, D, A. As you can see, all the elements in set A are also present in set B. They are exactly the same. Therefore, we can conclude that A is actually equal to B. So these are equal sets. On the other hand, we have here equivalent sets. We have A here, set A, that is equal to A, B, C, D, E. And set B, we have 1, 2, 3, 4, 5. So take note that these are entirely different. However, if you're going to count the number of elements in set A and B, they are both 5 elements because 1, 2, 3, 4, 5. And then in set B, we have 1, 2, 3, 4, 5. So both have the same number of elements. They have 5 elements containing in these two sets. So in this case, we can call this as equivalent sets. We also have this what we call types of sets according to the number of elements. So we can identify what type of set of this depending on the number of elements. So let's say for instance, we have a finite set. When we say finite set, this is a set having a fixed number of elements, or this is countable. When we say finite set, all the elements that can be written using the roster method or the tabular form, the elements are counted. You can count that one using your counting techniques. Example, we have set A that is 1, 2, 3, 4, 5. As you can see, we have here only 5 elements. So this is countable. You can count the number of elements in the given set. Another example, we have set of officers in a class. So we have here set of officers in a class. If you're going to count the set of officers in a class, you can actually count the members or the officers in a class. And lastly, we have the third example written in the set builder notation, x such that x is a whole number less than 100. So if you're going to count the numbers less than or whole numbers less than 100, you can actually count the number of elements. And for that, we can call this one as a finite set. We can count the number of elements in a finite set. In the infinite set, we cannot count the number of elements because an infinite set is a set without a fixed number of elements. You cannot count the elements in this given set. So let's say for instance, we have a set of numbers. How many numbers do we have? If you're going to count the numbers we have in counting, that is actually infinite. We cannot end. You cannot count. There is no end and there's no beginning for a given number. However, if there is a limit, let's say for instance, set of numbers from 0 to 10, that can be counted because there are actually 11 elements present in that set. But if you have set of numbers only as the description, you cannot count all the numbers in the given set. Set of natural numbers. Okay, so we have here set of natural numbers. Set of natural numbers, when we say natural numbers, these are numbers or simply what we call the counting numbers. This number begins with 1 and it will be followed with 2, then 3, 4, 5, so on and so forth. There is no end. So since there's no end, that is infinite. And we have x such that x is a negative number. So the biggest negative number is actually a number is, I think that is between negative 1 and 0. So you cannot count that also. And all the numbers less than that. So that is not countable. So therefore, this one is an infinite set. If the given is number of leaves, we can count the number of leaves because that is actually countable. That it will just take time, but that can be counted. Grain of rice, that can be counted. It will just take time, but that can be counted. So those are not those are not infinite set. The next one is what we call the singleton set. So when we say singleton set, that from the name itself or from the word single, that is a unit set or within or a finite set with exactly one element. So this is a group wherein the member is only one. So if you have a group chat and there is a one member, that is a finite set. I mean a singleton set. There is only one element. Okay, example, we have a set of the President of the Republic of the Philippines. There is only one President of the Republic of the Philippines. Therefore, we can say that this set is a singleton set or a unit set. The second one is 0. So if you're going to count the number of elements in this one, that is only one element. So this one is what we call singleton set or unit set. Then lastly, we have x such that x is an even prime number. So even prime number, what is that number which is an even and also prime? So even number that is divisible by 2 and prime that is a number with wherein the factors are the given number and 1. So therefore that is 2. Therefore C is also a singleton set or a unit set because an even number or prime number is 2 and there is no other element in this given set builder notation. That is what we call the null set or empty set. So when we say null set or empty set, it has no element. This is a finite set with no element. Example, a set of months with 40 days. Do we have months with 40 days? Exactly none. Therefore, that is a null set. That symbol can be written this way, or X such that X is a dinosaur living in 2020. Do we have a dinosaur living in 2020? Absolutely none. Therefore, that is a null set or empty set. So these are the important terms that you should be reminded of because we will be using these terms in our next lesson. So thank you very much for listening. I hope that you learned something.